Hello students, happy morning. In today's class, we are going to solve the last exercise of the chapter triangles. So before we start solving the problems, I wish to recall what are all the concepts we learnt in the chapter. So first, to start with, we have learnt what is basic proportionality theorem. What is basic proportionality theorem, which is also called as Thales theorem or BPT, right? Which says if a line is drawn parallel to one side of a triangle to intersect the other two sides in two distinct points, the other two sides are divided in the same ratio. I repeat, if a line is drawn parallel to one side of a triangle to intersect other two sides in a distinct points, the other two sides are divided in the same ratio. Which means if DE is parallel to BC, then AD by DB is equals to AE by EC. In further problems and further classes, we have solved even one more result, which is AD by AB, the full side, which can also be obtained by adding or subtracting 1 to the corresponding ratios. Hope you remember. AD by AB is equals to AE by AC, or AB by AD, or AB by BD. In whatever way we want, we can do it by adding or subtracting 1 to it. So this is basic proportionality theorem. After this, we have learnt converse of BPT, which says if a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. Yes, so converse of BPT is also true. So then we have solved problems related to BPT and its converse. Then we have learnt criteria for similarity of triangles. When two triangles will be called as similar? If they are of same shape. So we don't bother whether they have the same size or not, but they should have all the angles, corresponding angles should be equal. The corresponding sides should be in same ratio, or else corresponding sides should be in proportion, right? Then only the two triangles will be called as similar. The symbol to denote similar is this, and we have learnt a few criteria for similarity of two triangles, which is AAA criteria, which says that if all the three corresponding angles of two triangles are equal, then the triangle will become similar. When AAA is possible, obviously 2A is possible, right? Because the third angle will become very well equal by angle sum property. So AAA similarity criteria, which implies a AA similarity criteria. Then we have seen SSS. If all the three sides are in proportion, then the two triangles will become similar. If all the three sides are in proportion, then the two triangles will become similar. Remember, when we talk about three sides, the three sides should be in proportion. It is not necessary all the corresponding sides should be equal, because we are talking about similarity of triangles, right? So from these two, what we infer, to prove two triangles are similar, it is enough if we show any two angles, corresponding angles are equal, or all the three corresponding sides are in proportion, because one implies the other. Then we have learnt one more criteria, which is SAS criteria. What does it says? The two sides should be, the corresponding two sides should be in proportion, and the included angle should be equal. If two corresponding sides and the included angle should be equal and the corresponding sides should be in proportion, then the two triangles will become similar, right? So what are all the criteria we have seen? AA similarity, SSS, then SAS similarity criteria. So totally we have seen 4 similarity criteria. So based on this, we have solved problems again. Then we have seen a theorem on areas of similarity of triangles. What is area of similar triangles? The ratio of the area of similar triangles will be equal to square of the ratio of their corresponding sides. Area of triangle ABC divided by area of triangle PQR equals to AB by PQ the whole square, or BC by QR the whole square, or CA by RP the whole square. Right? When we talk about similar triangles, the correspondence is very, very important. I am insisting right from day 1 of the chapter. So kindly remember. area of similar triangles, the ratio of the area of similar triangles will be equal to the square of the ratio of their sides. Right, then we have solved problems based on this, and at last we have seen Pythagoras theorem. Before solving Pythagoras theorem, we have solved one more theorem which lays base for it. That is, if a perpendicular is drawn from the vertex of the right triangle to the opposite side will be the hypotenuse, right? So if a vertex is drawn if a perpendicular is drawn from the vertex of the right triangle to the hypotenuse, then the triangles on both sides of the perpendicular will be similar to each other and also similar to the whole triangle. These two triangles will be similar and each triangle will be similar to the whole triangle. Right, this theorem also we have seen. After this, using this theorem, we have proved Pythagoras theorem. Pythagoras is well known. We know already. What is Pythagoras theorem? In a right triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. We have proved this using similarity criteria. Then the converse of Pythagoras theorem. In a triangle, if the square of one side is equal to the square of the sum of other two sides, sum of the squares of the other two sides, then the angle opposite to the first side is a right angle. Right, so these are all the things we have learnt in this chapter. First, to start with BPT and its converse, then 4 criteria for two triangles to be similar, then a theorem based on areas of similar triangles, and then Pythagoras theorem and its converse. Before that, one more theorem which lays the foundation for Pythagoras theorem. So these are all the things we have learnt in this chapter. Why am I recalled all these things? Because only if you remember all these things, we can solve our next exercise, because it's going to be a miscellaneous exercise. So far we have learnt one concept, and based on that concept we have solved the entire exercise, right? So we have completed the chapter. The last exercise is like a miscellaneous exercise which involves all these concepts. So when you look at a problem, all these things should line up in your mind, and you should think which concept should be used to solve that particular problem. Yes, I hope I recalled all those things. Let us move on to the exercise and solve it. Yes, the first question in exercise 6.6. It is given PQR is a triangle in which PS is the bisector of angle QPR. Right? PS is the bisector of angle QPR. We need to prove QS by SR equals to PQ by PR. Right? QS by SR equals to PQ by PR. So when you look at this problem, how can we prove this correspondence? How can we prove this ratio? If we prove these two triangles are similar, then we can show that the corresponding sides are in ratio, right? But to prove the similarity of these two triangles, we don't have any input apart from PS. PS is the angle bisector. Therefore, this angle will be equal to this angle, and we don't know any other information about other angles or sides of these two triangles. So we can't prove the similarity of these two triangles as such with the question. So what are we going to do now? We are going to extend our triangle. We are going to do one construction here. So what is that? Draw a line segment RT parallel to PS. We are going to draw a line parallel to PS which intersects this QP at T. Right? And whenever you see the correspondence like this, two things should strike your mind. One is BPT and other one is similarity of triangles. Using basic proportionality theorem also we can say the corresponding sides will be in proportion by if we have a line parallel to the other line. So keeping that in mind, we are constructing a line RT parallel to PS intersecting QP at T. Right? Now let us proceed with our proof. Now we are going to solve this using basic proportionality only. We have drawn RT parallel to PS, and already it is given in the question this angle is equal to this angle, right? So angle QPS is equals to angle SPR, which is given in the question. Now RT is parallel to SP. Then what we know, if two lines are parallel, this angle will be equal to this angle, right? This angle will be equal to this angle. Why? If we consider these two lines as parallel and PT as our transversal, these two angles will become corresponding angles, right? So angle QPS will be equals to angle RTP, or else you can write QTR, since corresponding angles are equal. Similarly, what about this angle and this angle? This and this will become equal, because if we consider these two lines as parallel and PR as your transversal, these two angles will become alternate angles. So similarly, angle SPR will be equals to angle PRT, since alternate angles are equal, right? So we have told that this angle is equal to this is equal to this is equal to this. Therefore, all these four angles have become equal now, right? So from 1, 2 and 3, what we infer? We get angle PTR will be equals to angle PRT. In the sense, this angle is equal to this angle. If these two angles are equal, what we know by isosceles triangle property, these two sides will become equal. So this implies PT is equals to PR by isosceles triangle property, right? Now in triangle QTR, by basic proportionality theorem, we are going to apply basic proportionality theorem. Since PS is parallel to TR, this line is parallel to this, right? So a line is parallel to the third side intersecting at 2 points. Then what we know, the corresponding paths will be in proportion. So QS by SR will be equals to QP by PT. QP by PT, right? But PT is equals to PR. So I can replace QS by SR is equals to QP by PR from 4. And this is what we need to prove. See, QS by QR equals to PQ by PR, and hence we proved. Hence we proved, right? So we have constructed this. If you don't know this part of the problem, if you don't construct this, we won't get the solution. So immediately a question will strike your mind. How do we know, ma'am, for which question we should do which sort of construction, right? All this lies on your regular practice. So if we do more problems on this chapter, you know, on looking at a problem, what you should do. Yes. So after completing this exercise, I try to give more additional problems for practice, so that on looking at a problem, you know how to start your proof, right? So once you know, see, for this problem, if we construct this, everything follows automatically, nothing difficult, right? So hope you understood. Let us move on to our next question now. Now let us move on to our next question. It is given triangle ABC is a right triangle. ABC is a right triangle. How do we know it's right triangle? In the question it is not explicitly given. It is given that D is a point on hypotenuse AC of triangle ABC. So automatically ABC is a right triangle, right angled at B, because AC is the hypotenuse, such that BD is perpendicular to AC, DM is perpendicular to BC, and DN is perpendicular to AB. So every side the perpendicular is being dropped. They asked you to prove DM square equals to DN into MC. DM square equals to DN into MC. Right, and dn square is equals to dm into an. So these two proportions we need to prove, right? So what's the idea behind it? How can we prove it? When we have solved problems of this kind already. When we have dm square, which means we might have got dm by dn or mc, which is equals to mc divided by dm. So it's like a proportion of the sides, corresponding sides. So when we cross multiply it, we will get a square term, right? So we try to prove the similarity of the required triangles. Then by the similarity criteria, the corresponding sides will be in proportion. So first, to start with, let us consider this BMDN, right? So consider BMDN quadrilateral, and what can you infer there? DN is parallel to MB, right? DN is parallel to BM and DM is parallel to NB with angle B is equals to 90 degree. Yes, both the pairs of opposite sides are parallel with one angle 90 degree. Therefore, it is a rectangle. So, this implies DMBN is a rectangle. What do you know about rectangle? Opposite sides are equal. This implies opposite sides are equal. So, which are the opposite sides? So, this implies BM is equals to DN and DM is equals to NB, right? Keep this apart. Now, we need to prove DM square is equals to DN into MC. So, which means we try to prove the similarity of this part of the triangle with this part of the triangle. We try to prove the similarity of these two triangles, because here only we have DM, which is common to both the triangles. So, when we write the ratio, we will get DM square, right? So, in order to prove the similarity of these two triangles, we need a minimum of two angles to be equal, right? But everywhere it is given 90 degree, 90 degree. So, let us find out a few relations here. So, first if you take angle CDB, what do you infer? It is given as 90 degree, right? Angle CDB is equals to 90 degree. So, to avoid confusion, let us first name all these angles. So, let us name this angle as 1, this as 2, this as 3, and this as 4, this as 5, right, and this as 6, and if we need further, we will name it. Now, if you consider angle CDB is 90 degree. Therefore, angle 2 plus angle 3 will become 90 degree. So, we are proving the first part. So, in triangle BCD, angle CDB is equals to 90 degree. This implies angle 2 plus angle 3 equals to 90 degree. Mark this as 2. Now consider CDM. In this triangle, what we infer? Angle 1 plus angle 2. In triangle CDM, angle M is 90 degree. Therefore, what about these two angles? Angle 1 and 2. Angle 1 plus angle 2 equals to 90 degree, because the third angle is 90 degree. In a right angle triangle, sum of the other two sides will be equal to 90 degree by angle sum property. Mark this as 3. Right. Now, in triangle DMB, again this angle is 90 degree. Yes. So, shall we name this as 7, this angle as 7, right? So, in triangle DMB, angle 3 plus angle 7 equals to 90 degree by angle sum property again, because this angle is 90 degree. If this angle is a 90 degree, the sum of remaining two angles should be equal. Yes. So, mark this as 4. So, what can you infer from all these 4 things? We can see that angle 2 plus angle 3 equals to 90 degree, angle 1 plus angle 2 equals to 90 degree. Therefore, angle 1 equals to angle 3, angle 1 equals to angle 3, and angle 2 equals to angle 7. Yes, this we got from 1, 2 and 3. Sorry, 2, 3 and 4. How we got this? See, angle 2 plus angle 3 equal to 90 degree. Here angle 1 plus angle 2 equal to 90 degree. Angle 2 same 90 degree. Therefore, 1 should be equal to 3. Similarly, if you compare second and the fourth equation, 3 same 90 degree. Therefore, angle 2 should be equal to angle 7. Yes. So, we got angle 1 equal to angle 3, angle 2 equal to angle 7. Angle 1 equal to angle 3 and angle 2 equal to angle 7. Already this angle is 90 degree. So, if you take these two triangles, we got angle 1 equal to angle 7, angle 1 equal to angle 3, angle 2 equal to angle 7. Therefore, two angles are equal. Therefore, by AA similarity criteria, CMD will be similar to triangle DMB. Right, CMD is similar to triangle DMB. Therefore, the corresponding sides will be in proportion. MC divided by MD is equals to DM divided by BM. Why we have taken this ratio? Because that's what we need. We need in terms of MC. So, we have taken that. Now, if we cross multiply, MC into BM is equals to DM into DM. So, MD is DM, right? So, DM square is equals to MC into BM is equals to what? BM is equals to DN. We showed BM is equals to DN because we need to prove in terms of DN. So, it can be written as BM can be replaced by DN. Right? We have told since it's a rectangle, this side will be equals to this side. We have done already. This is from 1. This is from 1 we have substituted, right? Hence we proved. So similarly you can prove the second part of the problem by considering these two triangles. Find out the relationship between all these angles. This angle you can name it as 8. This is also 90 degree. So 5 plus 6 will be equal to 90. 4 plus 8 will be equals to 90. So from these two you can equate which two angles are equal. Therefore, by AA similarity criteria, these two triangles will become similar. Again, you can apply corresponding sides will be in ratio. You will get your answer. So, I am leaving the second part to you. Nothing difficult in this. We have applied the similarity criteria. Before that, we tried to find out which angles are equal, because only if you know at least minimum of two angles are equal, we can apply the similarity criteria. Since we don't know any relation about the sides, they have given you few angles are 90 degrees. So with that we have derived the relationship between the angles and then we applied the similarity criteria. Hope you understood. So I am leaving the second part to you. Prove the second part by your own. Let us move on to the next question now. Let us see how can we solve a third question. ABC is a triangle in which ABC angle is greater than 90 degree. AD is perpendicular to CB, right? Now we need to prove AC square equals to AB square plus BC square plus twice BC into BD. On looking at this itself, immediately what theorem strikes your mind? Pythagoras theorem. And one angle is 90 degrees. So we are going to apply Pythagoras theorem here. So in triangle ADC, AC square is equals to AD square plus CD square. Now CD we can write it as BD plus BC, right? DB plus BC. Those CD can be written as BD plus BC. So I have replaced CD as BD plus BC the whole square because we have CD square. At the same time, AD square can be written as AB square minus BD square. Why we have replaced all those things? Because the thing which we need to prove doesn't have AD, right? So we have replaced AD in terms of AB. AD square can be written as AB square minus BD square, right? Now expand this using A plus B the whole square identity. BD will get cancelled. So the remaining things, that's what we need to prove. So proof follows very easily. So the next question is also in the same way. See in figure 6.59. ABC is a triangle in which angle ABC is less than 90 and prove that So similarly, if you apply Pythagoras theorem and if you write one side as the sum or difference of the other two sides, because here we have 90 degree here, so we have written BD, sum of two sides, as your base, but here we have 90 degree here. So we can apply Pythagoras theorem for this triangle and this triangle separately. So when we need this, you can write it as BC minus BD, right? So if you express in that way, you can arrive at the answer easily. Similarly, the fifth question as well, applying Pythagoras theorem repeatedly for each and every triangle. Here angle M is 90 degrees, so you can apply Pythagoras theorem to triangle AMD and also to triangle AMC and also to triangle AMB. You can apply Pythagoras theorem to all these three triangles. And you can, and also given that AD is the median. AD is the median of triangle ABC. If AD is the median, what you know, it will divide into two equal halves. It will bisect. So BD equal to DC, or else BD can be written as BC divided by 2. Similarly, DC can be written as BC divided by 2. Right, that's what we got, BC divided by 2 in the proof and all. So if you repeatedly apply Pythagoras theorem, you can easily arrive at the proof of fifth problem as well. We have two more subdivisions in the fifth question. So see, we have two more subdivisions in the fifth question which can also be arrived easily. So I wanted you to prove fourth and fifth question by your own, and if you have doubts, you can ask me. So with this, let us wind up today's class. Do these problems as homework, and if you have any doubts, you can contact me in between of the problem. If you have any struggle or difficulty to continue with your proof, you can very well ask me then and there. I am ready to help you out. Practice all the problems. Only if you do regular practice, you can get this chapter, or otherwise it will be like what to say, very it will be like vague concept. So if you do regular practice only, you will get it, right? Hope you understood. Do these problems as homework and post it in the group. Thank you, students.